welcome my friends to another Small James PowerPoint presentation where I'm going to teach you everything you should know about the backend. As always, if you enjoyed the video, smash the like and subscribe button so that I can continue to feed Doug, my beautiful corgi dog. So to understand what exactly the backend is, we first have to understand the context in which it exists. And that realm is known as the full stack. Basically, the stack is a sandwich of technologies that come together to make a product or an application using different segments of code. Essentially, it's comprised of two main parts. One part is the backend, which we'll be discussing further in this video, and the second part is the front end. And if you're unfamiliar with the term the front end, basically what that is that's just the user interface of whatever it might be that you're building. So wherever the user can interact with it, that's known as the front end. Now, if we want to talk more about the backend, it's honestly better to ask, what isn't it? And as you might have guessed from that first slide, we know that it's definitely not the front end because it works in collaboration with the front end to develop the full stack. But more specifically, it is all of these things in addition to so much more. We've got databases, authentication, testing, caching, ORM, CI/CD, logging, security, serverless computing, and a bunch of other words that you might not be familiar with now, but by the end of the video, they will be a lingo that you feel confident using on a regular basis. So there's loads of stuff you can do with backend, which leads us on to the next slide, which is how exactly do we go about building one? Now, at its very core, the backend is developed with programming languages. There are many that you can use to develop a backend, such as Python, JavaScript, Ruby, PHP, C#, Java, Rust, and a whole lot more. And in the brackets at the end of every line, I have what is known as a framework, where a framework is basically an adaptation or an extension of the programming language with some predefined tools that can make it a lot easier to develop these backend applications. My personal favorite is JavaScript with Express, where Express is known as a web server. We'll talk more about that later, but Express is basically just some pre-built functionalities that I can use to whip up my backend in JavaScript much faster. Each of them has their own trade-offs in terms of the benefits and advantages, but if you're just getting into it for the first time, often Python and JavaScript are going to be the easiest to get up and running. Now, we need some additional context before we dive further into the realm of backend programming, and that is an understanding of the internet and how it works. Basically, the internet is a product of the full stack. A lot of us have this conceived notion that it's just this magical, ethereal thing that exists in the sky and we just all connect to it. But the reality is that the internet is basically just billions of programs built in programming language, billions of backends around the world, all running on hardware that are connected to one another. Basically, I have code on my computer. I could set that up as a backend, and it can communicate with other programs around the world that together give us the sense of being connected, and we can interact with them throughout a web browser where the communication is just generally referred to as the internet. Now, another term that's commonly thrown around when we talk about backends is the server or the server side. Now, this term is important when we think about the backend in the context of the full stack, which we learned about earlier. The full stack is the front end and the back end. And if we look at this first point right here, your experience of the internet, you might be consuming this video on YouTube, your experience of the web, what you've got open on your browser, is known as the front end. Now, the front end exists on your computer. It's your browser. Your browser reads information, displays it on your screen, and that is referred to as client side. You are the client, you are the user, and so the front end is running on your device. If you don't have your computer, you don't have your front end. So if the front end is on your computer, then whereabouts is the back end? And in contrast to the front end on the client side, the back end runs on the server side, where the server is an external piece of hardware that you connect to from your computer. Now, all of the backend code often runs server side, which just means that once again, it's on some kind of remote hardware running a process, and you're just connecting to it via the internet. So that's a little bit about the terminology of server side. Server side is code that runs on hardware somewhere other than your computer, so it's often more secure, and that has a number of other benefits. This also is a good opportunity to introduce the concept of the cloud. It's something you all might be familiar with. The cloud is kind of like some meta terminology for what we would also refer to as server side. The cloud is like an external machine that we can connect to, except instead of it being a piece of hardware, we kind of experience it through a browser. For example, if you go to Google Drive, you upload your photos to Google Drive, It's essentially still just Google's hardware running somewhere else. However, you experience it as if you're uploading it to the internet. Now, to continue our knowledge of backend development, we're going to ask a question. How do things go live on the internet? How is this video live on the internet? And the answer is what's known as a web server. Now, we kind of touched on the terminology of server-side. That's code that runs on a machine somewhere else. And now we're throwing the prefix of web in front of that term. And basically, a web server is, as we kind of talked about before, it's a tablespoon of programming logic running on the back end, in addition to a tablespoon of internet functionality, so connectedness with other devices. Together, they create what we refer to as a web server, where once again, that's just a piece of remote hardware somewhere that has a program that's constantly running, and it's listening for what's known as a network request. Now, a network request is the basic communication trail of the internet. So where if we went to a postman, for example, we might drop off a letter at the post and that gets couriered from one post office to another and then it gets delivered. The web server is kind of like the postman, and the letter that we send and the courier services themselves, instead of saying postage, we would call that a network request. So my computer, I can be on the internet, I can be on the front end, the client side. My computer can send a network request to a web server that's located somewhere around the world on some piece of back-end hardware with some server-side code, and it's listening for these incoming requests where we can then run some programming logic. Now, the continuation of a web server is a database. And this comes into play when we start to discuss how do programs and websites save my information. And we can actually continue the postman example to understand what a database is. And we can just ask, what happens when the postman saves a letter? He stores it in a little cubby hole. Well, basically a database is the same thing. We send our letter from our home address to the postman. They look after it until it gets delivered to another address, for example. In the same way, we can send information to a database which is likely running on some hardware, some server-side hardware around the world, and our information just gets stored in that hardware. Now, there are two main types of databases. One is known as a structured query language database, or SQL or SQL. There are a lot of different ways people refer to it, and we can kind of think of this as storing information in a spreadsheet. It's very structured, it's very organized. We can have different columns and rows that are related to one another. And the three most common databases that we use are MySQL, PostgreSQL, SQLite. There's a whole lot of them that you can choose from. My personal favorite is PostgreSQL if you're looking to get into it. But that's just actually the first type of database. There's another type of database that we can use to save information, and that's known as a NoSQL database. And this is kind of like a dictionary where we might have a word and we can look up the word in the dictionary and we can see the information that is associated with that word. So for example, if I look up James, the definition that's associated with James might be exceptionally cool. In the same vein, we can save information like that. For example, we could save a username and we could have an associated value of James. Now, three common NoSQL databases are Firebase, that's my personal favorite, MongoDB, and Redis. But once again, there are loads of options out there for you. Now, on the topic of databases, there's one other thing we should talk about, and that's what's known as an ORM. And this is a term that confused me a lot when I was learning to code, and it just means object relational mapping. Now, that probably still doesn't mean a lot to you, but in essence, what it's used for is when we have a SQL database, an ORM allows us to act with a data structure that's kind of set up like a spreadsheet. It's not a perfect analogy, but it's close enough. And it allows us to interface with it as if it were a programming data type. So instead of us having to go and manually enter in the data to our database, we can use programming languages in collaboration with some object relational mapping technology, such as SQLite, and that gives us a library of tools that we can use to effectively interface with our databases. So we talked a bit about web servers and databases, and they're all happy days, but the next thing we need to discuss is how do websites talk to each other? And you might just say it's the internet, but it's actually more complicated than it just being the internet. And instead, it's via a technology or a concept that we refer to as an API. Now, I'm going to tell you what API stands for, and to this day, it's still a whole lot of words that don't really help you to better understand the topic. but essentially it's known as a application programming interface. Now, as I said, that kind of looks like jargon. It's just a whole lot of words strung together, and so that's why people just commonly refer to it as an API. But another way that we think of APIs is also in association to what we refer to as an endpoint. Now, when we were talking about servers before, we build up a server. It typically has an intended purpose or functionality, and we also established that we can connect to it and do stuff with it remotely. For example, with Google Cloud, we can have a functionality where we can upload a picture and it's then saved to hardware somewhere remote or in the cloud. Now, when we build that functionality on the server, we develop what's known as an API endpoint. And what this means is that when we interact with the front end and we upload our photo gets pinged over the internet via a network request to an API endpoint, where that's kind of like the end destination where that information or that photo is processed. So a real life example might be you have to submit your taxes via post. You post your tax information to a destination. It gets received at the center and then your tax information gets processed. That's kind of equivalent to how an endpoint is. The tiny little office of employees where they process your tax information is kind of like the endpoint, the end destination. And often these endpoints are located by what's known as a URL, where an example of a URL is www.smalljames.com. That's referred to as the domain smalljames.com. And then we have a route or a path that is roadmap. If we talk about the roadmap example specifically, when you go to www.smalljames.com/roadmap, what's actually happening is your browser is sending out a network request to actually get some information, and then the server sends back the information required to load the web page on the screen. And that's what you then see and experience. If you weren't connected to the internet, you wouldn't be able to send that request to get the website, and that wouldn't be able to be sent back to you either. Now, a common way that we configure these API endpoints and the communication between them is via a RESTful architecture. This is basically the same as when we have our postage system. We have different stamps, we have different labels, you need to fill out certain information. Well, the same thing happens with these network requests. We have an architecture or a design on how to effectively implement them into our code. Within that architecture, we have what are known as HTTP methods, where HTTP stands for Hypertext Transfer Protocol. That's not really too important. You'll see that come up a lot though. HTTPS, the sibling to HTTP, is just a more secure version of that, but the methods are the critical part. When we send these network requests to our different APIs, we can structure the request with different verbs for different functionalities. And an example of this might be you could send a letter into a government organization requesting information, and in the realm of programming, you'd slap a big get on top of that. That's a get verb because the action is to get information back. But if you were sending information to them so that they could process it and save it in their databases, you would be posting that information to them. It might go to the exact same office or the exact same API endpoint, but the verb allows you to further specify exactly what the intention of that network request or that postage is. So basically, they're just associated with different background functionalities. Now, naturally after that, we've built a website, we know how to connect to the internet. How do websites actually know that it's really me? And this comes down to security and authentication, which is another huge component of backend programming. An example might be that currently you are logged into YouTube. That authentication process is handled in the backend of YouTube's servers. They've got a whole lot of backend code that makes sure that you are the correct person and that someone else isn't logged into your account. In short, hackers are bad. For example, someone could hack into your account and sign you up for YouTube Premium, and that's however many dollars out of your pocket, and you didn't even choose to do that. And the examples get much, much worse. But even further than that, hacking into people's account and faking authentication is by no means the end of security. You also get people trying to bug up your code. A good example of that is what's known as a SQL injection. If you remember earlier, we talked about SQL databases. It's one of the most common types of databases, and it's a relational database. And there's a language that we can use to interface or interact with the database, save, retrieve, access, update information. And there could be some bad hackers out there that use what's known as SQL injection to try and take advantage of your database and get back user passwords. They could hack into all sorts of accounts, and it's really not good. So a big part of backend development is implementing preventative measures to stop these kind of attacks. Another one is a DDoS attack. And this is totally different, but basically if I have a website on the internet, it's served up from a server. The server has that information and it sends it out as people access that website. Now, if I only have 2 to 4 people coming to my website, that's pretty low traffic. And if I've deployed it, I probably don't have very high costs. But if I were to have 2 million people coming to that website, that could be a very different story and it could be a very expensive website to host. Now, what people can do is known as a DDoS attack. They can basically make it seem like there's 2 million people accessing your computer, even though they might only be one individual and one piece of hardware. Now, that's super rude, but basically you could get slammed with an absolutely massive bill. And so we also need to design preventative measures for DDoS attacks. And there's a whole lot more. Some of that also includes stuff like hashing and encryption and making information more secure, but that's a huge component of backend programming. Now, the next component of backend programming that we're going to talk about is what's known as CI/CD, or continuous integration and continuous deployment. And this is an answer to a question that people might have, which could be, how do coders ensure their code works before putting it online? Now, this is super critical. For example, if you're deploying code at Facebook and it goes live and it's buggy, then that's going to be a big problem. Likewise for yourself, you could be building some stuff and you want to have it live on the internet. How do you do that effectively to make sure that it's functional, everything is working properly? You use a process known as continuous integration and continuous deployment. And this is yet again another component of backend programming where you just have another body of logic or a pipeline to ensure that you have effective deployment of your code to the interweb. You could run tests in this process, you could do all sorts of verification checks, and that's a huge part of running a website or a service. And that also begs the question, can we run websites without a traditional server? And the answer to that is yes, we can also do that, and that is a portion of backend programming known as cloud infrastructure or serverless programming. Now, these are terms that are very popular at the moment and they get thrown around a lot, but the funny thing about cloud and serverless technology is that it's actually just more servers, except a lot of big companies like AWS, for example, might pre-configure some processes so that you can just plug and play much faster than you would if you had to build the entire system from scratch. A good example of this is Cloud Functions. Basically, instead of building an API endpoint that might return some information or a website, I would have to set up that whole process, go and deploy it. It takes absolutely ages. Instead, what I could do is just log into a cloud environment, for example, Google Cloud Platform, and I can just write some code and hit run, and it's going to run on their systems. It's live on the internet. And that was a very streamlined process where instead of me figuring out how to deploy it, Google Cloud Platform has basically just said, give us your code and we'll do it for you. So that's another absolutely great tool that you should be aware of if you're going to go into backend programming, especially on AWS. They have about 100 million cloud services that you can take advantage of. There's even courses out there that teach you specifically how to develop applications so that you can take advantage of AWS's cloud or serverless systems. A big part of this is also cost-benefit analysis. When you launch infrastructure, often it costs money to run the hardware to serve up your programs, your applications, so you need to be able to analyze which one is most cost-effective for the service that you're trying to provide. And we're down to the last one, last but not least, and this is by no means an exhaustive list, but the other one that is huge for backend development is testing and monitoring. How do you make sure that your code does what it's supposed to? And basically, the thing you should know about this is that users are extremely unpredictable. Even if you think you understand how they're going to interact with your site, from my own personal experience, I can guarantee that it is unimaginable how unpredictable users can be. And consequently, a huge proportion of effective backend programming is going to be testing and monitoring. Now, testing makes sure that the functionalities that you've built out and you've deployed work perfectly every time so that people can't come in and break them. And there's 3 main types of tests that you can write. And the tests basically emulate user behavior so that you can check that things are working before the user goes ahead and finds out that it's not working, because that's not going to be good for them. Unit tests are for testing specific units or code bodies. Integration tests check the functionalities between things, and end-to-end testing is a comprehensive testing suite that should cover just about everything. And the other part of this process is monitoring your users. Nowadays, we have so much technology available to us that we can very easily see how our users are interacting with our websites, what behaviors we didn't predict, what we did predict, where we could optimize some types of behaviors. And this is also a super important thing to do as an effective back-end programmer. Now, that's not everything that's involved in the realm of back-end programming. That is just the tip of the iceberg. But it is a vast ocean that you can explore. Other things include caching, microservers, queues, background processing, version control, performance optimization, documentation. The list goes on. But at the same time, it's all absolutely worth learning, and on your conquest for becoming the ultimate developer, I definitely recommend exploring. There's so much out there that you can look forward to, and if you're looking for a place to get started, there's a Node video linked in the description down below that I would highly recommend checking out. It teaches you the fundamental principles of backend programming with Node.js and Express.js. And with that, we have covered our introductory guide to backend programming. If you've enjoyed the video, smash the like and subscribe button. And if you want, you could join the channel, pick up a membership. It helps support the videos that I make. Love that support. Catch you guys later. Peace. Learning to code? If so, be sure to check out the Learn to Code roadmap or dive straight in with these videos. That's a good one.